In this video, I'm going to talk about how to solve simultaneous equations when coefficients of both unknowns are different. Make sure to watch the part 1 of this video series. Okay, let's take two equations, equation 1 and equation 2. Okay, we need to find the value of x and value of y. So what we do is we eliminate one unknown and try to find the value of the other unknown. Hope you remember, for us to eliminate one unknown, we normally select the unknown that has the same coefficient in both equations. So do we have an unknown that has the same coefficient in both equations? No, right? We don't find. Now what are our unknowns? It's x and y. The coefficients of neither x nor of y are equal now. Therefore, as our first step, we need to make the coefficients of one unknown the same. So which unknown do you select to make its coefficients equal? Let's say I select x. Now I need to equate the coefficients of x in both equations. The coefficient of x in the first equation is 1. Then the coefficient of x in the second equation is 2. So how can I make them equal? If I multiply the first equation by 2, I can easily take 2 here. X times 2, it's 2x. So I can easily equate the two coefficients of x. What about y? Shall we try to equate two coefficients of y? Now y in the first equation, the coefficient of y is 2. In the second equation, it's 5. So how do I equate these two? Now in this case, we need to multiply both the equations to make both coefficients of y the same. Now the coefficients of y is 2 and 5. So I can actually equate them to 10, which means I need to multiply both the equations. So I will have to multiply the first equation by 5 because 2 times 5 is 10. Then I need to multiply the second equation by 2 because 5 times 2 is 10. Anyhow, this takes time, right? So remember to select the unknown that you can easily make its coefficients the same. So I'm going to equate the coefficients of x. Now what I do is I'm going to multiply first equation by 2. So let's multiply. X times 2 is 2x plus 2y times 2 is plus 4y equals 10 times 2 is 20. And let's name this equation as equation 3. Now notice here, the coefficient of x in the second equation and the coefficient of x in the third equation are same now. So we can easily eliminate x. Now check the signs here. Here it's a plus. Here also it's a plus. So same signs of the coefficients. which means we need to deduct one equation from the other. So are we going to deduct third equation from the second or the other way around? Look at the numbers on the right side. It's 20 and 2. So it's better to deduct 20 from 2. This means I'm going to deduct second equation from the third equation. So let's deduct 2x plus 4y minus, put the brackets, 2x minus 5y equals 20 minus 2. Now let's remove the brackets. 2x plus 4y minus times 2x is minus 2x. Minus times minus 5y is plus 5y equals 18. Now we can cancel plus 2x and minus 2x. Then 4y plus 5y is 9y equals 18. So y is 18 divided by 2, which is 9. Y equals 9. Now let's find the value of x. So I'm going to substitute into first equation by substituting y equals 9 in first equation. Our first equation is x plus 2y equals 10. Y is now 9, so 2 times 9 equals 10. That means x plus 18 equals 10. Now x is 10 minus 18, which is minus 8. X equals minus 8. I think it's better to check our answer. So let's substitute x and y to the first equation. X is minus 8 now, plus y is 9. That means 2y is 2 times 9, 18. Minus 8 and plus 18, it's definitely plus 10. That means 10. So our answers are correct. Okay, then let's solve these two simultaneous equations. Equation 1, equation 2. Now again, as the first step, we need to check whether we have an unknown which has the same coefficient. But in this case, we don't find. Coefficients of both unknowns are different. So in this case, we can select either to equate the coefficient of m or n. Now if I multiply the second equation by 2, I can equate the coefficients of m. And if I multiply the first equation by 2, I can equate the coefficients of n. So here I'm going to select m. So I'm going to multiply the second equation by 2. M times 2 is 2m, plus 2n times 2 is plus 4n, equals 4 times 2 is 8. And this is our third equation. Now our coefficients of m is equal. And the signs are same. Therefore, I need to deduct. So I'm going to deduct first equation from the third equation. The third equation is 2m plus 4n minus, within the brackets, 2m plus n equals 8 minus 5. So 2m plus 4n, when I remove the brackets, minus 2m minus n equals 3. Now I can cancel 2m and minus 2m. So I have eliminated the unknown m. Then I can easily find the value of n. 4n minus n is 3n equals 3. So n equals 3 divided by 3, which is 1. Then I'm going to substitute n equals 1 into the second equation. Second equation is m plus 2n equals 4. M plus 2, n is 1 now, which means 2 times 1 equals 4. So m plus 2 equals 4. And m is 4 minus 2, which is 2. M is 2. If you want, you can substitute the values of m and n to any equation and check your answer's accuracy. Okay, let's move into the next pair of simultaneous equations. This is our first equation. The second equation is here. Now let's check the coefficients of unknowns. We can see that there are different coefficients of both unknowns. Anyhow, we need to equate coefficients of one unknown. So which unknown we should select now? In this case, if I want to equate the coefficients of x, I can multiply the first equation by 3 and second equation by 2. So I can equate 2 and 3 to 6. Or if I want to equate the coefficients of y, I can multiply the first equation by 2 and second equation by 5. That means I'm going to equate 5 and 2 to 10. Anyhow, I'm going to equate the coefficients of x. So first equation, I need to multiply by 3. 2x times 3 is 6x plus 5y times 3 is 15. Y equals 9 times 3 is 27. So second equation, I'm going to multiply by 2. 3x times 2 is 6x plus 2y times 2 is 4y equals 8 times 2 is 16. Here it's the third equation and this is our fourth equation. So what are the signs of the coefficients of x? Both are pluses. This means we need to subtract one equation from the other. So I'm going to deduct fourth equation from the third equation. Left side of third equation is 6x plus 15y minus, within the brackets, left side of the fourth equation, 6x plus 4y equals 27 minus 16. Let's remove the brackets. Minus 6x and minus 4y. 27 minus 16 is 11. Now we can eliminate x. Plus 6y and this minus 6y. We can cancel them. 15y minus 4y is 11y equals 11. So y equals 11 divided by 11, which is 1. Y equals to 1. Now let's substitute and get the value of x. So I'm going to substitute to the first equation. 2x plus 5y equals 9 is our first equation. You can substitute to any equation. Here I have selected first equation. 2x plus 5 is 5 times y. So 5 times 1 now. 2x plus 5 equals 9. So 2x equals 9 minus 5, which is 4. So 2x equals 4. X equals 4 divided by 2, which is 2. X is 2. So shall we check our answer? If x is 2, 2x is 4. Plus, if y is 1, 5y is 5. 4 plus 5 is 9. So our answers are correct now. Y equals 1 and x equals 2. Okay, what about these two equations? Equation 1, equation 2. Now I'm going to equate the coefficients of n. First equation should be multiplied by 2. And second equation should be multiplied by 3. Okay, let's multiply. 4m, I'm going to multiply the first equation now. 4m times 2 is 8m minus 3n times 2 is 6n equals 7 times 2 is 14. This is our third equation. Then the second equation we need to multiply by 3. 7m times 3 is 21m minus 2n times 3 is 6n equals 22 times 3 is 66. And this is our fourth equation. Now again look, the signs of the coefficients of n is the same. This means we need to deduct. So I'm going to deduct third equation from the fourth. 4 minus 3. 21m minus 6n minus, within the brackets, 8m minus 6n equals 66 minus 14. Remove the brackets. Then 8m and minus times minus is plus, plus 6n. 66 minus 14 is 52. Now let's cancel minus 6n and plus 6n. 21m minus 8m is 13m equals 52. So m is 52 divided by 13. M equals 4. Right, then we need to substitute into one equation. By substituting m equals 4 in, let's choose first equation. First equation is 4m minus 3n equals 7. So 4m, m is 4. That means here it's 16, 4 times 4. Minus 3n equals 7. So minus 3n equals 7. When I transpose this 16 to the other side, it will become minus 16. So 7 minus 16 is minus 9. Minus 3n equals minus 9. So 9 is minus 9 divided by minus 3, which is 3. N equals 3. Okay, let's check our answers. I'm going to substitute to the first equation. 4m. M is 4, therefore here 4 times 4, 16, minus n is 3 now. 3 times 3 is 9. 16 minus 9 is, it's 7. Okay then. One last pair of simultaneous equations. This is the first equation, the second equation here. Now, again, the coefficients of both unknowns are not similar. So I'm going to equate the coefficients of y. If you want, you can equate the coefficients of x. So 3 and 2, we can equate them to 6. So I need to multiply the first equation by 2 and second equation by 3. So let's multiply the first equation by 2. 8x times 2 is 16x minus 3y times 2 is 6y equals 1 times 2 is 2. And this is our third equation. And let's multiply the second equation by 3. 3x times 3 is 9x plus 2y times 3 is 6y equals 16 times 3 is 48. And this is our fourth equation. Now we see that the coefficients of y are same and the signs are different. That means we need to add 3 and 4 in order to eliminate y. So 16x minus 6y plus 9x plus 6y equals 2 plus 48. Minus 6y and plus 6y, we can cancel each other. Then 16x plus 9x is 25x equals 2 plus 48 is 50. So x equals 50 divided by 25 and our x becomes 2. So by substituting x equals 1 in the first equation, 8x minus 3y equals 1 is our first equation. X is 2 now. This means 8x is 8 times 2, which is 16. 16 minus 3y equals 1. So if I transpose 16 to the other side, it will become 1 minus 16. And this side we have minus 3y. So 1 minus 16 is minus 15. Minus 3y equals minus 15. Therefore, y equals minus 15 divided by minus 3. It's plus 5. So y equals 5. Okay, once again, let's check our answer. Let's substitute to the first equation. X is 2, so 8x is 16 minus y is 5, so 3 times 5 is 15. 16 minus 15 is 1. Yes, our answers are correct. I hope that you understood how to solve simultaneous equations when there are different coefficients for both unknowns. Okay, then see you. Don't forget to subscribe.